In this lesson, we're going to start to talk about a little bit with some roots. And so we have two different kind of situations that we're going to look at that we're going to have positive. We're not going to have any negatives onto these things. We're either going to have odd or we're going to have even. Right. So remember that even kind of has some, so if you do a quick, this is like a cube root kind of a graph. And so visually you're looking at something that might look like this. And this might be a square root kind of a graph. So visually, you might have something like this. Square roots are going to have domain issues, fourth roots, sixth roots, but odd roots are not going to have domain issues, which also means there's going to be no breaks in the graph. All right, so that's what they're talking about. It's going to be continuous. All right, so, but if you're talking about an even root, you're going to have a domain issue. And so as long as it's within the domain, you're not going to have any breaks, you're not going to have any asymptotes, nothing like that. You just have to figure out where the domain is on it. So it says we're trying to find the values of x are the following functions continuous. So where's this one continuous? Where's this one continuous? So let's start with this one. So this is a 1/2 power square root, has a domain issue. We don't want to square root any negatives. So we got to figure out where this is positive and where this is negative. So since it's an even root, right, we need to remember that this 9 minus x squared needs to be greater than or equal to 0. Okay, because we're not doing imaginaries. So how do you solve that? Well, in order to solve that, it's not as straightforward as you would like to think. Let's do this way. Let me rearrange this whole thing. I'd like to factor and treat it like a quadratic. And so I'm going to apply a negative to every single thing. So I'm going to basically distribute a negative. So that's going to make it a negative 9 plus x squared is now it's going to make it a less than or equal to 0. I'm going to rewrite that real quick. X squared minus 9 less than or equal to 0. And then I'm going to factor to find some critical numbers. So I need to factor this into an x plus 3 and an x minus 3. So my critical numbers are x equaling negative 3, x equaling 3. So here's what that does for me. So I have a negative 3 and a positive 3. I'm going to go back to this, or actually I can go back to right here, equal to 0. And I want to test out, because it's an inequality, we typically get a range of values. And so range of values that work, range of values that don't work. If it was an equal sign, we get just individual numbers that work. So these critical numbers are going to be these breaking points of when things work and when they don't work. So if I plug in a negative 4 into this, I want to test each of these regions and see where does this thing make less than or equal to 0. And so if I plug in a negative 4 here, I would have a negative here times a negative here, making this overall thing positive. And a positive value is not going to be less than or equal to 0. So that's not going to work. If I plug in a value in this range, let's say a 0. If I plug in a 0, I'd get a positive in that parenthesis and a negative in this parenthesis, and they would multiply to a negative. A negative value is going to be less than or equal to 0. That's going to be a good section. And then over here, we could plug in a 4. That would leave us with a positive here. And a 4 minus 3 is a positive here. And if you multiplied them, you'd get a positive. So for us, what would work would be values between negative 3 and positive 3. Then I just have to check, can I include the negative 3 and the positive 3? And yes, because we want things, we can square root zeros. That's what these critical numbers are. They're what happens if you plug in negative 3, you get a 0, which is okay because you can equal 0. So where is this thing continuous? It's continuous from negative 3 to positive 3. Anytime you have a square root, you kind of have to do a little bit of an inequality because of the fact that this needs to be positive or 0 or greater in order for you to kind of continue. So that would be our continuity where our graph is continuous. Another way to think of this is kind of recognizing where this comes from. And you might or might not recognize that, but you eventually will probably do enough of these that you'll recognize it. That this actually comes from, so here's kind of a pre-calc way to do it, is that this actually comes from x squared plus y squared equaling 9. And let me show you how that becomes that. is that if I solve for y, I would subtract the x squared. So I would get a 9 minus x squared, and then I would square root. And so technically I'd get a plus and a minus. 9 minus x squared, and this equation is just focusing on the positive. So what that graph actually looks like is recognizing what this graph looks like. This is an equation, this is a circle with a radius of 3. So visually, you'd have a circle that would kind of look something like that, but the positive square root would be this section, and the negative would be this section. And since we're not doing the negative side of this part wouldn't exist for us. So the graph of this is actually coming from half of a circle. Would be coming from the top half, and there's your domain from -3 to +3, and it hits them, so then we can include it. And so that's a different way to look at it, but sometimes that's a good way to look at it for some visual people. And then this last one. This last one, if I take a look at this 2/3, the root on it is odd. Odd root. And the odd root is the denominator. So an odd root is not going to have a domain issue. So it's going to be continuous everywhere, right? So that whole thing is going to be continuous. So f of x is continuous from -infinity to infinity. And as long as that doesn't have a problem and that doesn't have a problem, so x squared minus 2x plus 4, it's continuous from -infinity to infinity. And so this has no problems, and so then cube rooting it also has no problems. So you kind of have to look on the inside and work your way out. All right, so that was doing some continuity with roots, and then we'll start talking about some other kind of functions.